All right, guys, welcome to Unit 14. This unit's all about these things called conics. And so we're going to introduce you guys to two big ideas here called conics, and a little bit later and in future lessons we'll talk about something called parametric equations as well. So without any further ado, let's go ahead and get started here. So today we're going to talk about what a parabolic conic is, how can we determine its features, and how to graph them. All right. So first of all, let's talk about what conics are. Basically, there's four types of conics, and all of them can be thought of as like some sort of a cross section of two inverted cones. So shapes that look like this are parabolas. We're familiar with those already. Shapes that look like this are circles. Shapes that are like stretched circles are called ellipses. And then these things which kind of look like parabolas, they're not, but they kind of do look like parabolas, but there's two of them and they go in opposite directions. Those things are what we call hyperbolas. And so those are the four types of conics that we're going to be discussing in this unit. We'll spend one day on parabolas, one day on circles and ellipses, one day on hyperbolas. After we talk about all those different conics, we're going to talk about parametric equations and how those relate to this concept. So why do mathematicians care about conics? Well, conics are actually pretty useful in modeling various real-life situations. Like, for example, most of our orbits that, govern how, the planets move around the sun or how moons move around planets are done by ellipses. Parabolas are useful for anything under the influence of gravity. So anytime you throw something, it's called a projectile. And projectiles are always modeled with parabolas. Parabolas can also be useful for satellites and other reflective surfaces. So conics of all kinds are all very useful and helpful for modeling real-life situations. So that's why we take time to study them. So as I mentioned today, our primary focus is going to be on the parabola. So what is a parabola? Now, you guys already know what a parabola is. So far this year, we've learned about quadratics. Quadratic equations can look like this, or they can look like this. But today they're gonna look a little bit more like this one, honestly, not this one at all. They'll look a little bit more like this, but even then they're going to look a slightly different in the way that we choose to write them, and there's a reason for that, because we're gonna give you a little bit better of a definition of what a parabola is now. A parabola is basically the collection of all points that are equidistant from a focus and a directrix. So for instance, this point right here, it is the same distance away from the focus as it is from this line here. In other words, this distance here and this distance here are equal. But that's not the only pair of points that are equidistant from that line and the dot. Here's another one. The distance from here to here is the same as here to here, and therefore that's another point. If you were to graph all the points that were equidistant from the focus and the directrix, you would find that you're basically tracing out a parabola. And so that's what a parabola is. In fact, this is where satellites come in pretty helpful. A lot of times they have when the light waves come in, right, they reflect off the surface and they all project into a central point. And so parabolas are really useful for modeling satellites because of that purpose. I don't know much beyond that, but I do remember studying that at some point. So there it is. So we have these three parts. We have the line down here called the directrix. We have this point inside the parabola called the focus, and all the points that are the same distance from that green dot and red line trace out the blue shape called the parabola. And the one right here in the middle is what we call the vertex, okay? So there's some vocabulary for you and some definitions about parabolas. Now let's move on a little bit. Okay, so now just as a preview here, we're going to talk about two different types of parabolas. Vertical parabolas, and what I mean by vertical is that they either open in an upward direction or in a downward direction. Then we're also going to talk about horizontal parabolas, and that's kind of a new concept for us this year. we've seen the vertical ones before, but horizontal is kind of new. And so by horizontal, I mean that they open in a rightward direction or in a leftward direction. So let's start by talking about the vertical ones. So first of all, the vertex has coordinates. We'll call them h and k. All right. Now here's our directrix that we talked about before. And here's our focus, which we've talked about before. And the distance between your focus and vertex, we're going to call that little distance there, I'll do it in red so you know what I mean. So this length right here, we're going to call that the p-value. Okay? Now, all that being said, we can put these things in a formula like this down here. The h goes here, the k goes here, and the p goes here. All right? Now, if p is positive, then we have an opening, a parabola that opens in an upward direction. But if p is negative, then we have our parabola opening in a downward direction. All right? And just so you guys know, once again over here, this is the vertex, so this would be h and k. And p would be the distance between the vertex and the focus there. Okay? So if the distance between them is positive, then that means that we're going in an upward direction. If their distance is negative, that means we're opening in a downward direction. And this is the formula for those. Now, something to take note of is that whenever you have a vertical parabola, the x minus h is being squared. Okay, so that might be a good note to add here. And I would just add that, draw a little parenthesis to that. And the reason that's important is because we're about ready to talk about horizontal parabolas, and it's actually a little bit different for those ones. And this is how you can kind of tell the difference. All right, so let's go ahead and take a look now at the horizontal parabolas. So this one is the vertex for these. Let me switch back to black here though. So there's my h and there's my k. The x value is the h and the k value is the y. And the p value, once again, is the distance from your focus to your vertex. Same thing over here. Okay, so now once again, if p is positive, then your parabola will open to the right. If p is negative, then your parabola will open to the left. And this is our little formula down here. The k goes with the y, and the h goes with the x. That's the same, and the p goes with the 4 there. But notice the difference here is that now the y minus k is here. With the last slide, the y minus k was on this side. But on this side, but now with the horizontal parabolas, the y minus k is over here. Okay, so there's our basic formulas there for both vertical and horizontal parabolas. So let's go ahead and do example 1 here, where we're going to analyze all the parts based on the equation here, and hopefully we'll be able to turn it into a graph also. All right, so here we go. So first of all, what is the vertex? All right, so the number that's with the x will give us the first part, the x part of our vertex. It's going to be 2, but notice I make it a positive 2 because it will always be the opposite sign. And then the k is the number that is with the y there, so that's going to be a -1. Notice once again, you also make that one negative. In the formula has both of these being negative, so it switches their signs. Okay. Now for the p-value is hidden here. I'll do this in a different color. The p-value is hidden in here. That's where the 4p is at, right? And so 4p equals 8. If you divide both sides, put a little division symbol there, you end up with p equals 2. Now this next question is, you got to think about two things at once here. First of all, which way does this parabola open? Is it vertical or is it horizontal? Look at this equation. Is that going to be a vertical parabola or is it going to be a horizontal parabola? Well, since the x minus h is being squared, this is a vertical one, which means we're not opening left or right. Now we have to decide, is it up or down? Well, since my p-value is positive, it must be opening upwards. Okay? Next, we want to find the focus, and this is where we actually want to start getting into some of the graphing here. So here we go. Let's graph this. Plot our vertex. My vertex is at 2, -1. And my parabola is opening in an upward direction. Okay, so, and my p-value is 2. So starting here from my vertex, I'm going to go up 2 spaces. 1, 2, and I'll put a dot there. You don't need to draw this line, but I'm going to draw it just so I can label it as p. Okay, so that's what I did there. So this is going to be my focus. And this is my vertex. And as you guys know, for the parabola, it's opening upwards, going around that focus like that. The focus will always be inside of your parabola. So since this was an upward opening parabola, I know that the focus has to go upwards from the vertex. Okay, so now what are the coordinates of this point? What do you guys think that would be? Well, it looks like it's over 2. And it looks like it's up 1. Another way you could calculate the focus is by taking your vertex and adding the p-value to the correct number. Now that's a little bit tricky. You may add the p-value or you may subtract it, and sometimes you'll do it to the x and sometimes to the y, depending on which way it opens. But if you took this 2 and you added it to the y value, you'd get this, and that's because we went upwards 2 points, and so that adds 2's to the y value. But personally, I think it's easier just to draw the graph and then figure out the coordinate after that. All right, now the directrix. What is the equation of the directrix? Well, let's draw it first. So the directrix will always be the same distance away from the vertex as the focus is, but it's on the opposite side. So my focus is 2 spaces away from the vertex. Therefore, my directrix will be 2 spaces away as well, just in the opposite direction. So here, my directrix will be down here. Now, a directrix is not a point, it's a line. So I'm going to draw a line. Now, the directrix, when it's a horizontal line, will always be y equals, and whatever number on the y-axis you're at. It looks like we're at -3. So the equation of the directrix is y equals -3. And then they want us to graph the parabola, but I was doing that as I did 4 through 6, so I'm done. Okay, so there is our first example. Let's go ahead and take a look at a second example here. Now this one's missing some numbers, so I'm going to start by rewriting this a little bit. The left side looks fine. The formula they're going for here is y minus k squared equals 4p times x minus h. Okay, so we're missing some stuff here. I've got a y plus 4, but I don't have the p or the parentheses or the h. So what that means is my x is over here. That's all it's over there. So that means my h is 0, and the number up here in the front is a 1. Okay, so I'm just filling in some missing numbers there. So what would the vertex be? What's the number by the x? Inside the parentheses, it's h is 0, so that would be 0. And then the number inside the parentheses with the y is 4, but we do the opposite sign, so it's -4. So there's my vertex. What's the p-value? Well, 4p equals 1. Which means that p equals 1/4. Or you could say about 0.25 if you want to write it as a decimal. That might come in handy a little bit later. All right, which way does this parabola open? this is one where I would encourage you guys to pause the video here and see if you guys could figure it out. The first thing you want to do is you want to think about, is it vertical or is it horizontal? And then after that, you're going to decide more specifically, is it which pair it is, because this is the vertical pair and this is the horizontal pair. So if you decide that it's vertical, it's one of these two, and if you decide that it's horizontal, it's one of these two. So pause the video and see if you can figure that one out. So our formula looks like this. So that means we're dealing with a horizontal parabola. And since I'm dealing with a horizontal parabola, it's either left or right. Now my p-value is positive, which means that it is right. So I know that my parabola is opening in a rightward direction. So at this point, we're going to start graphing to answer questions 4 through 6. So let's plot our vertex. My vertex is 0, -4. And my parabola is opening up towards the right. So it'll look something like that. Now, the next thing is asking us to find the focus. Now, I know the focus has to be inside the parabola, and the p-value tells me how far away it is from the vertex. So if this is 1, the focus is going to be really close. It's going to be like right about here at positive 0.25. Okay, and the directrix will also be behind it, but let's finish the focus actually first. So what are the coordinates of this point? Well, I went over 0.25, or 1/4, and it still has a y value as the same as the vertex, which is -4. So the equation of the focus is positive 0.25 and -4. What is the equation of the directrix? So the directrix will be the same distance away from the vertex as the focus is, just in the opposite direction. So instead of going forward 0.25, we're going to go backwards 0.25, which would be like right about here, and we draw a line. Now for vertical lines, we use x equals instead of y equals. Remember on the last problem we put y equals something. But for vertical lines, it's x equals. And in this case, x is equal to -0.25. And at that point, we've also done number 6. It's also been completely graphed. So there you guys have it. So let's go ahead and put you guys to work here on this. Here's 2 for you. Go ahead and see if you guys can work these out. Pause the video. When you unpause it, I will have the solutions up for you. All right, so here are your solutions. I'll let you guys go ahead and study that for a second. I'll take a minute to describe some stuff here on the second problem over here on the right. Since p is 0.25 and my vertex is here at 1 and it opens upwards, if I go up 0.25, then I'm at 1.25. And so my focus will be this. If I go down 0.25 from 1, then that puts me at 0.75 for my directrix. Okay? Notice that the directrix here is y equals, and over here it's x equals, because for vertical lines we do x, and for horizontal we do y. All right? Let's go ahead and move on to our next topic here. We're going to review an old topic known as completing the square. Completing the square is a process where you create a perfect square trinomial. You cut this in half. Half of 4 is 2. And then you square it, meaning raise it to the second power. And then put it here. Okay? So half of 4 is 2. And if you square it, you get 4, and you put that there. And the benefit of this is that when you factor it, you get the same factor twice. In other words, x plus 2 squared. So we can actually skip that middle step and just remember it's always going to be, when you factor it, it's always going to be x and then something squared, and whatever goes here is half the middle number. So in this case, half of 4 is 2, so that's what goes here. Okay. But you do have to remember about adding this other new number in there. That will come into play, but it just kind of, in a sense, it kind of gets hidden and obscured when you factor it. So there you go. All right, so that's review. We haven't done that in a little while, but we are going to use that today. So let's go ahead and, okay, so here's our second example. We want to write this parabola in transformational form. That means I want it to either look like this, or I want it to look like the other one, which is pretty much just the same thing. It's just the parenthesis portions are swapped around. So that's the goal, is I want to get it written in that form, all right? So the first step that we want to take is we want to move the part that has a square and the other variable that matches that. So in other words, the x's. I'm going to move the x's to the other side and leave everything else on the same side. So I'm going to subtract the 2x squared, and I'm going to add the 4x, just like that. The result will be we have a negative 2x squared on the left as well as a positive 4x, and then everything else will still be on the other side. Okay? All right, so the next step is we want to factor out this number in the front here. So take out the leading coefficient out of the x squared term. So in that case, we want to take a negative 2 out, and that will leave me with x squared minus 2x. Notice that this became negative because if you divide 4x by negative 2, it leaves you with negative 2x, right? The other side is going to stay the same for now. All right, next thing we're going to do is we're going to complete the square. All right, so we're going to be creating a new number right there. All right, and how do we create that new number? Well, you take half of this, which is negative 1, then we square it, meaning raise it to the second power, and put the result here. Okay? Now, I just added a number to this side of the equation, so we need to fix the balance of our equation now. So how do we do that? Well, we'll leave this side alone for a minute. And to fix the balance, since I added something on the left side, I also need to add something on the right. Now you might think that I have to add 1, but we don't actually. What we need to add is we need to multiply the 1 by the negative 2 first, because by putting 1 in there, it's actually being multiplied by negative 2. And so negative 2 times 1 is negative 2, and that's what you put over here. So we're going to add a negative 2 on this side, like that. Our next step is to factor the left side and combine on the right side. So we're going to be factoring this right here. Now you could do it the old way, but I've shared with you a shortcut. The shortcut is that it's always going to look like this. The only thing is we just need to figure out what goes there. And what goes there will always be half of this middle number here. Okay? And so half of negative 2 is negative 1. So that's what goes there. So that's the quick way to factor it. But if you want to do it the old way, you can. And on this other side, we're going to combine these two things together, 2 and negative 2. And they just so happen to make 0. All right. Now this next step, typically I wouldn't even put plus 0 here, but to make a point, I want you to be aware of a step that typically happens next. So if I have a 0 here, I really don't need to do this next step, but I'm going to do it anyway because your problem will probably need it. So what we're going to do is we're going to factor out the coefficient on the other side. So what do I mean by that? So I want to take that negative 3 out. So once again, this left side is going to stay the same for now. But on the right side, I'm going to take out a -3, and we're dividing it out. Now, if you divide 0 by -3, it's still 0, so that doesn't change anything. Okay? Now, in the next step and the last step is to divide this number to the other side. And actually, I just misspoke. We don't want to divide the -3. Actually, we want to divide this one out. So we're going to divide both sides by -2 like this. That way this is gone. And now we have x minus 1 squared. Over here the negatives cancel, and I'm left with a positive 3/2. And then you could put y plus 0. There's no harm in that. And there it is. So now we're done. So we've changed it from this form into transformational form. And now why would we want to do that? Well, because now we can see what the vertex is, we can figure out what the P is, we could just figure out which direction this parabola is opening, and so on and so forth. So there's a lot of steps here. Now, if you didn't do this, I would encourage you to do this now before we move on to the student practice. I would write down these steps that I've written down to help you out, because there are quite a few of them. All right. So for the student practice, we're going to treat it kind of like a guided practice, where I'm going to let you guys do one step at a time, because there's a lot involved there. But let's go ahead and have you guys give it a shot. Here we go. So go ahead and pause the video here and do the first step, and when you unpause the video, you will see the solution. So this is the result of the first step. You should have added the 2y squared to this side, and you also should have subtracted the 4y to this side, and the result is 2y squared minus 4y equals the other two things that were left on the other side, -x minus 3. All right, so let's go ahead and pause the video here and have you guys try the second step. When you unpause it, you will see the solution. So step 2 was to factor out the leading coefficient on the squared side. So we divide both of these by 2, and we get this, and we put that 2 that we took out in the front. So go ahead and pause the video here, and let's give the third step a try. The third step is to complete the square. So that's where you take half of this number and square it, and that gives you 1. So that's what we add in there. All right? So go ahead and pause the video here and try the fourth step. All right, guys, so there's your fourth step. That's the one where you multiply this 2 times the 1 and then add it over there. All right, so go ahead and pause the video here and let's try the fifth step of the process. So the fifth step is where you factor this, and when you do that, you get y plus 1 squared. And also where you combine the -3 and 2 on the right side there, and you get that. All right, so let's go ahead and try the sixth step, I believe we're on now. All right, so the sixth step is where on this side, you're going to factor out the leading coefficient, which is a -1. So if I divide that out of both terms, this is what I would get. All right, and then one more step, the last step, so go ahead and pause the video here and give that one a try. And when you unpause it, you'll see the final answer. All right, the last step is where you divide the number in front of the squared, the coefficient in front of the squared expression to the other side, which gives you -1/2. And so we have our final solution there. And as you can see, if I wanted to, I could graph this one now. I see that its vertex would be -1, -1. I also see that the p-value is going to be negative, so it's opening to the left at -1, -1. So we can find our focus and our directrix, etc. We're not going to do all that here, but just wanted to point out what we could do now that we've transformed it. Okay, so there's that. And I think we'll go ahead and call it quits there, and we'll put this stuff to practice when we get back to class. See you guys then. Bye-bye.